From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and concerned citizens making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Assistant Professor in Pollinator Health in the Department of Horticulture.
I don't have to tell you that honeybee societies are remarkably complex, and as such, their response to environmental stressors is often not straightforward. And I run into this situation all the time as I train pesticide applicators across the state of Oregon on how to use pesticides in such a way that won't have an impact on honeybee colonies. So you can just imagine my delight when I started to flip through the pages of a new publication from the pesticide program at Purdue University called The Complex Life of the Honeybee. Now, the primary author on the book is my guest today, Dr. Fred Whitford, who is the director of the Purdue pesticide program, which he's been since 1991. In that time, he's published over 300 publications, including 8 books and 140 extension bulletins. Dr. Whitford knows how to reach an audience and how to get a complex message across to them. The other truly remarkable aspect of this book is the author list. Dr. Whitford has gone far and wide to find the top bee toxicologists from the university system, from the Environmental Protection Agency, and also from industry. And we're going to be joined by one of those authors, Max Feken, who's an environmental toxicologist who's worked for Syngenta for 8 years. And he's primarily focused on risk to pollinators. And what's going to come across in this episode is not only the complex life of bees and not only the complex interaction between bees and pesticides, but the new Environmental Protection Agency framework for assessing risks to bees. And this is really the only publication I've ever seen that explains, outside of EPA documents, how this framework actually works. So without further ado, let's launch into the complex life of the honeybee, their interaction with pesticides, and the new regulatory framework at Environmental Protection Agency for assessing risks to bees. All right, well, welcome to Pollination. I have with us today Fred Whitford.
Well, thanks for having me from rainy Indiana.
And I've got Max Feken.
Thank you. Thanks for inviting me. Appreciate it.
Well, I'm so glad to have you guys here. I was, oftentimes something comes across my desk and I think, wow, that is remarkable. Where did this come from? And this publication that we'll be talking about today, The Complex Life of Honeybees. And just to begin with, what was the motivation for publishing this book, and who's the audience that you thought it was targeting?
Well, as I develop publications here at Purdue University through the Extension Service, that's part of my job is to have outreach, and I'm supposed to be talking to people and trying to explain whatever the issue is. And on this particular one, you have an issue that people are very passionate about. You have an issue that's been with us for a long time. And so when we look at honeybees, and everybody loves honeybees, but what we're trying to do is to merge two complex issues: honeybees, a living organism, and pesticides that we use in our crop production systems across the board. How do you take the two issues that in themselves are extremely complex, and then you mesh them together? And so the idea is, how do we give people information? Let's say that you're a master gardener, as an example, and you love honeybees. And I do a lot of master gardener programs, and they love their honeybees. They love their pollinators. It's even broader now. How do you get information beyond I love something or I hate pesticides? They're all bad for our pollinators. Well, you don't have very much information. It's just from the heart. Then you have let's say the pesticide people. You have those folks that understand the pesticides, but they may not understand specific ones, understand the bees and how they move and how it interacts. So my goal is always, how do I teach myself, because I'm a generalist, how do I bring both the bee and then the complex part of the pesticides? And there's somewhere, that Max comes in, because he understands the science of honeybees and pesticides. That's his job, right, Max? That's what you do for a living.
Yeah, that's correct. And how I got involved was Fred Whitford had called me up. I've never met Fred before, but he's actually a really convincing salesperson in terms of getting folks involved in this effort, which, this takes quite a bit of work to put together a document like this. And what really sold me on it was that he introduced it as a way to provide information to policymakers, is what's really got me excited. So it's really going beyond just the lay person, but including some additional information to really help, in particular, policymakers in understanding this process. So in my job, we do a lot of explaining, trying to explain certain aspects of science. And with pollinators and the honeybee in particular, there's really, the understanding of the actual honeybee itself and all the complexities of bee health. And then that's even before you get to the risk assessment process. That's really where I come in and was helpful, hopefully, in help describing that process, which takes up a big chunk of the overall document, which I think is really what makes this document unique.
I love your answers, because as an extension specialist myself, I know that often when it comes to pollinators, there is this reaction. It's like, who would want to harm pollinators? But then you get into the complexities of the life cycle of the bee. And then for a pesticide applicator, another group that I interact with, and I'm, Fred does as well, they have all sorts of things going on that they have to manage. And then bees are just one part of it. And so bringing the complexities of the bees into sort of their decision-making process. And then there's also policymakers, and, pesticide regulation and the risk assessment is complex and it's hard. Those EPA documents are very long. And so trying to render it out into something comprehensible, I think that is Extension's role. And, I want to just kind of maybe pivot to sort of the bee part of it, because I think here it's been really, you've done a wonderful job of taking a very complex life cycle and kind of taking out the key aspects. And I imagine in writing, you must have been tempted by sidetracks. This part isn't explained, or tell me a little bit about how you prioritize material to get this key message that you were trying to convey down.
So the object is, as we talked about, I'm a generalist. I'm self-taught on everything that we work on. I have a degree, but my degree is not in honeybees or pollinators. It's not even in pesticides. I was a crops person. So what I have to do is to teach myself the subject matter. So in this case, Max was one of from the person who understands the testing. We had Tom Seeger, who from EPA. We had our bee person here. So what I do is I lay out on paper what I'm interested in, because see, Max doesn't realize it, but he created a monster when he taught me. So Max was teaching me, our bee guy was teaching me, the EPA person was teaching me. And I have an outline where I like to go. And then, so what I would do is interview them. And I would say, well, tell me, Max, how do pesticides interact with bees? And Max would give me an answer, and then I would go deeper. But the problem is Max wants to go to a lot deeper than I want to go, because to me, it's not as important. I get lost in the details. So I carried Max to a certain point, or he carried me there. And I think after that, it was, that's deep enough for people like me, my reader, agency people, and even people in Max's company. Max, you have people who sell, you have people who do research on crops and pests, and And they need to know up to a certain point, and that's where we reach. So I write it all and try to get this information, and present it in a way that's understandable with as much as possible without the jargon. And then you get to the part at the end of risk assessment, which takes a little bit of jargon. It requires you to understand how things are looked at. So then we do a national review. We want to make sure that what I have on paper, and then we do a lot to do things like with photographs, illustrations, a bunch of those kinds of things for those that don't like to read. Maybe the picture and a detailed caption is all that they want, right? So we're trying to capture stuff, but you're right, it stays focused. And then the authors review it, and Max may have said, Fred, you missed this. Or Fred, this is not right. Or this is a lot of detail. Maybe this doesn't quite fit here. So it's a lot of give and take between all of the parties. And again, Max could carry me into the deep the bowels of bee biology and pesticides, and that's why it's good to have these experts that know their specific area, so that we come up with a publication that's nationally reviewed, and people don't have a lot of arguments about what we say. But you have to be willing to read, right? I mean, these issues are complex. They're not easy. I can't do it in an email. It's not a one-page fact sheet. If you want to understand bee biology and pesticides, you got to read something. And that's, again, the purpose of the publication. So, again, Max, would you add anything to what my long-winded answer? But
yeah, I mean, like Fred, I'm more of a generalist, and I'm an environmental toxicologist. So I look at impacts of pesticide across different taxa, including pollinators. But Fred was able to recruit Reed Johnson from Ohio State University, and he's a real bee expert, and he also is very familiar with the concept of pesticide exposure and effects. So I think really the key was getting the message of the background on the bee life cycles, and also really focus on actual bee health, because really when you talk about impacts of pesticides, it's really hard to tease away the other aspects of the bee health in general that are impacting colonies in the U.S. and throughout the world. So it's really important to cover those aspects of it, because it's so crucial in understanding, the overall impacts on pollinators in terms of how this may impact pollination services for agriculture, but also for biodiversity. So these are very important considerations that you can't really isolate. And it really goes back to the colony collapse disorder. That was really big topic back in 2006 and 2007. And really what the experts were able to sort of tease out is it's really complex assortment of issues that the bee, concerning bee health, including varroa and other diseases that are vectored by the varroa mites. But those are important considerations that you need to take into account, and that's why I think there's real focus on that this document on the bee health issue.
Actually, that's a great example, Max, of looking at health. So I write history books. And so I've been writing about, I think we're working on our 8th or 9th book now on the role of extension. And now we're working on the Great Depression, World War II. But if you go back to the earlier days, we were losing 50, 60, 70% of our hives every winter. And this is before there's any chemicals. And it had to do with bee health. And so critical. So right now, and I think you were talking about there where you're at, that you had a lot of rain and bee activity is being impacted. Well, these bees are under a lot of stress now. They're not bringing in as much food. They're consuming food in the hive. And so the stress of what we have all during the year impacts our ability to go into winter in Indiana. And if we're weak going into winter, Max, we're going to have problems with those hives surviving. It takes a number of individuals to keep the colony warm. And there is an example of a simple fact. I got a group of bees that cluster around the queen, and their job is to try to keep them warm. Well, if I don't have enough of them, then the colony dies. So that's an important fact to know. So Max said varroa mites. Back then, it was all kinds of diseases. The ability, Max, to have a food source, not to take as much honey away from them. I don't know, and the list goes on and on, right? All of those impact, along with pesticides. It's these pieces that all fit together. And that when he says bee health, that is so important. And any of your beekeepers there, whether they're hobbyists or major players, understand how important that bee health is, and specifically varroa mite as probably the best example that detracts from that health.
You know, I those are all excellent points. I think people don't realize that some of the biggest legislation around bees happened in the 30s around American foul brood, because, you know, many states still have them on the books, the bee acts. Yes. And, you know, it was, you know, an amazing loss of colonies, and it did require, you know, it was a different, you know, at that time, it was like this a completely different agricultural system. And yet, you know, bees were dying. But I guess.
But what they did, not to interrupt, what they did, you would have a state inspector that would inspect your hives. And if you had it, you burned your hives. I mean, that was the control measure, was to burn everything that you had. And so it was serious, but that was part of that disease. Even back there, part of that plant health. Not plant health, the bee health. It was part of maintaining a good, strong colony. We talk about that strong colony. Well, that has meaning.
And I think that's an excellent point as well. You know, oftentimes, you know, Oregon, a pesticide investigator will be dispatched. Sometimes it's clear what happened. You have a classic case of an acute, you know, something happened, something was in bloom, exposure took place. Oftentimes, the investigator can't figure it out because there's so many, it becomes such a complex web of things that could have gone wrong. It's not very easy for them. You know, they can take analysis of, you know, things, and it's just not clear why that colony died. And any apiary inspector knows that. Sometimes retrospectively, because it is complex how a colony can decline. And I guess, you know, one thing I just wanted to, since we're talking about pesticides, I thought one thing that has happened, you know, Max was talking about the incident, you know, the kind of period of 2006, 2007, and that EPA really overhauled, you know, how it assessed the effects of pesticides on bees, and, you know, put a risk assessment framework in place. I think this publication that you have is the first extension publication that tries to explain the nuances of this risk assessment. And I wanted to just, you know, having gone through the EPA guidance documents and seeing how some of those charts that they have, they're flow charts that are just, you know, they're very hard to follow. What was your approach to being able to convey the meat of the risk assessment without getting lost in the kind of like detail?
So the question, and that's part of what Syngenta does, and the rest of the companies, they have protocols they have to follow. And EPA wants to ensure that the products that we use are going to have no to minimal impact on honeybees. So that's the bottom line. So EPA has a set of tests that they require all of the manufacturers of these products to go through. And depending on what you find, you have to do more and more and more. So this is where the biology comes into play. And so it's not to say that, this herbicide or this insecticide or fungicide if they're all bad, you have to go back to the biology. Where do these animals come in contact with it? Where does these products that we use to grow the food that we're going to be eating, the food and fiber, where they come in contact? So you go back to the biology. Well, you got the adult that's foraging. You have the adults that's getting nectar, which is different than getting pollen. And then you're bringing it to the hive. And what happens when it comes to the hive? The nectar that is regurgitated back to another one who's going to move it. Another worker is going to move it through the system. The pollen that's fed. And so then you can see this movement. And now you understand why the tests are done the way that they're done. And then you say, does it kill them? Okay. Does it impact the colony? And Max, I've always used about 10% of the colonies dying anyhow. I think it's about 10%. Every day, these adults are dying. They're burning out. A honeybee can only fly for so long until they wear out. It's just like a car that's gone beyond its miles. And so it has to replace them. So if the chemicals have an impact on the brood, then you could have impact on numbers, which impact the foraging, which impacts into winter survivability here. So I'll turn it over to Max. But if you understand the biology, then the tests that EPA requires, and I don't know, Max, if it's costing us now $500 million, about almost 10 years worth of research to get these products registered, it would be pretty stupid for you to send out a product that does harm, right? I mean, it would just be taken off the market.
Yeah, I mean, it is expensive to register new active ingredients for sure. And really, I mean, I think you're right, Anthony. It's this document is the first one I'm aware of, an extension document that describes the new risk assessment process for pollinators. And the primary author of that was Tom Steger. And part of my job was to help sort of streamline some of the text because, you know, the guidance document, the EPA guidance document for pollinator risk assessments came out in 2014, and those documents are available for people to read. But as you mentioned, it's not necessarily something that will keep you awake at night if you wanted to read that. So it's a real struggle, you know, trying to explain science in a process like this, which is pretty complex, in a way that you keep people's attention, but without, you know, sacrificing the necessary details. And I think we struck a nice balance to describe this process. So it's really, you know, in the past 10 years, the way that the bee risk assessment process has advanced is really impressive. And so prior to that, there was really only a couple of acute toxicity studies that were required. And really what the focus was, you were trying to prevent a bee kill from happening. And to now with this system where we're actually have multiple laboratory tests, including testing honeybee larvae and moving to a higher tiered process where you do actual field work, to understanding the nuances of the risk to pollinators, to not just focus on mortality, but actually looking at sublethal effects and ultimately any impacts to the actual colony itself. So this is really a good place to help try to understand this process more. And again, I think Fred's intention was to have a document that would help policymakers, but also I think it could really help with environmental groups and other groups that actually want to take the time to learn some of the new nuances to the risk assessment process, which is now required for all outdoor pesticides, so not just the neonicotinoids. I mean, they were really the first drivers to advancing this process. But it's required for all pesticides, whether it's a herbicide or an insecticide or a fungicide. So that's a really important thing that I think a lot of folks don't understand, and hopefully this document will help provide that information to them.
Well, I like the way that Fred also set it up in terms of that the risk assessment is trying to capture a biological process, and the publication's written that way. Here's the biological flows of how materials come into the hive and how they are distributed into the sort of superorganism that is a colony. And then followed up with a description of the risk assessment is trying to sort of mirror that process, so that when a new chemical is registered, it's thought of, is exposure going to take place? And if exposure takes place, is it, does it have these very direct, immediate effects? Does it have these more slow manifest effects? And, moving through the process, that there's a kind of, I like the way the publication tries to, the way that Fred described it, bridge those two pieces together.
It's kind of a storytelling, right? As a scientist, we don't necessarily process information that way, but I think in some cases, what Fred has brought out here is really telling a story. So I think that's really a great approach to it.
Well, go ahead, Fred.
Your whole point was so exposure, and again, that's what we try to get here. Just because there's exposure to an animal, to a human being, doesn't make it bad. Then again, it could. How do you know that? So if you measure exposure at different parts on a honeybee, on the colony, an individual, then what do those numbers mean? And you go back to what Max was talking about, the studies that determine at what level can we kill? We can kill, we keep increasing the dose till we find out what that number is. And then I can make a comparison of what is my exposure to the bees, do we know actually causes harm, and where am I at in that range? And so that's where we look at this exposure information and why that's so important. It's not, they're exposed, that's bad. No, it's not bad. The same reason that I can I can control varroa mites, right? What do we use now to control varroa mites?
Number of amitraz, oxalic acid, formic acid.
It doesn't kill my bees.
Mm-hmm.
But there's an example of it's not always just exposure leads to harm. Now, again, sometimes it might be. And if that's the case, then that's what Max and them was going to have to go to the next stages that says, we're going to have to study the hive. Let's look at the hive in an enclosed area, and let's see what actually takes place. And so they're really trying to quantify in greater details as it goes forward. And then Max would know that at some point, it's not worth generating more and more information. That EPA is asking for more and more. Then maybe we need to find, if possible, another product. But that generally doesn't happen because the EPA guidelines are set up that Syngenta, in this case, knows exactly what the game is, right? And the game is science. How do we identify the things that EPA and their panels have said are important? And so when we all come out of this, we feel pretty comfortable that we can use products. Now, what we haven't talked about is obviously there is the biology and there's the science. There's a missing component here, and that's called the applicator, the business. That is called the people who are expected to follow the directions on the label, right, Max? I mean, that's why you have product labels.
Mm-hmm.
He's going to convey, and when it comes down to it, you can see that some of these products will tell you, do not spray. In fact, I'm working on a mosquito publication now, and almost every one of the labels, it says, do not spray while bees are foraging. Well, bees don't visit things that don't bloom because they need nectar and pollen. So there's a reason that we have those statements in it, because we can, in fact, kill bees by direct application. But our growers, our master gardeners, our homeowners, all of those people are asked to follow the label, environmental statements, to see if there's something on it about killing bees or impacting bees. And that is, in fact, putting science now to work. And it's that level that a lot of us will spend time. And, I could ask a lot of your listeners, when's the last time you used a product? Did you follow the label? Did you even look at the label? No, you looked at the rate is what you did, and you made the application. And that's where, if we follow the labels, I'm under the opinion, Max, again, I don't work for a manufacturer, but we follow the label. I feel very confident that what we could do is make applications that are safe. Heck, I work with the orchard people. They need honeybees, because without honeybees, I don't have any fruit. I don't have any fruit. I have nothing to sell. So it's following the directions. Which on rates, Max, what would be some other things? Rates would be timing, warnings. If we do that, we are not going to impact bees. Now, that's a pretty black and white statement, but I feel pretty comfortable in what the testing is trying to get us to do.
Well, I would say the thing that I'm really heartened with as a pesticide educator myself is that the language on the label is much clearer than in the old hazard statements. There are statements there about petal fall, about beekeeper notification. And it's great to know that I think this is a point that you were getting across, Fred, that each of those statements is backed by a risk assessment process, which is quite conservative. I've heard somebody recently told me that, there's a perception out there, these tiers, the kind of laboratory tests, many products go right to the second tier because of the level of conservative, the regulators are being very careful. The thresholds that have been set very kind of conservatively. And so oftentimes we're going to, more realistic scenarios. I just feel like, I know that these statements are clearer than, how do I tell if a product's going to wear off overnight? The old labels, it was complicated. Here it's just clear as day.
Yes.
Yeah, there's definitely more work we can do in that area. We need to make the labels clearer, and my push is to have pollinator specific language for each crop directions for use. So then you get rid of the ambiguity, and if it's clearly it should stay whether or not you can do application during bloom, and if not, what other steps you need to mitigate exposure.
Well, I guess what I'd also maybe want to just kind of wrap up on were what kind of feedback are you getting on the publication? Are you hearing? It's relatively new. I heard about it. I was really excited. But from the public, from policymakers, from stakeholders, tell us a little bit about what the experience of this publication in the world has been.
So for me, it's been great, to increase my own knowledge, which is what my intent was. I thought the publication came out extremely nice with all the photographs, but what it's done for me is opened up a lot of doors to give these presentations. And so when I go in front of industry groups, or I speak to master gardener groups as the example, or I speak to some, let's just say the Syngenta technical staff and or the marketing and salespeople, that's where, we're able to explain something in a much simpler way to frame what it is that we do and don't know. And so it's been extremely well received. We've already been through a couple of printings. We now give this to all of our bee clubs that we have in the state because they're asking for it. And from that, then it spawned 5 or 6 more, like what happens when the state is going to do a mosquito. They're going to treat for mosquitoes across a large area. So now we know that how does that impact the beekeepers? So it has spawned a lot of things beyond this. So I've been extremely pleased that we can contribute something like this, and that Max was part of it, and EPA was part of it, or these scientists were part of it. I'm looking through our list here. Our integrated pest management person was part of it. Reed Johnson, that Max talked about, that we could all come together versus this is good and this is bad. That we could all come together and say, okay, we agree to these facts. For the most part, this is pretty solid. And anymore, I think, Max, that's pretty important that we have some consensus instead of black and white, right and wrong, left and right. And consensus building is still extremely important, in my mind, at least as an educator.
Yeah, but what's nice about it, I mean, it really describes the bee health issues in the process, and it's not tied to any particular insecticide like the neonicotinoid, so it doesn't necessarily have that baggage with the controversy around neonics, whether they're bad or good, but it's really describing the process that's been set up. And we've had really good feedback. I try to promote it as much as I can. That's why it's really nice to have like this podcast to talk about it. And we share it anytime we speak to a state legislature. We share that document to help to educate, really of all the nuances to the new risk assessment process. And it's, there's so many facts that folks just aren't aware of in terms of what's now required for determining risk to pollinators. So this document, I think, goes, a step forward and help to explain it.
Well, fantastic. Well, we will have a link to the publication in the show notes, so you can download it. And I have to say, the graphical rendering of some of the key concepts is some of the best I've ever seen. It's really wonderful. Okay, well, let's take a quick break, and then we're going to come back. We have a segment that we do with all our guests about book recommendations and other things. So we'll take a quick break. We'll be right back. Just to start with, Fred, or maybe start with you. We'll start with Max. Max, do you have a book recommendation?
Yeah, so I was thinking of a pollinator-related book that I've recently read. And actually, I listened to it in my car to driving into work. Is Tom Seeley's Honeybee Democracy.
Oh, yeah.
And what's really fascinating, I mean, the topic of how honeybees swarm and the process of deciding where they swarm and the location they're actually going to end up being is really fascinating. But what really was interesting to me was Dr. Seeley, how he described some of his early studies on understanding the swarming process and just the his thinking on the study designs is what really intrigued me. So that's my recommendation.
His books are always so great because he has like a sustained set of questions that he tackles over a decade. It's not like I do a lot of research. It's like on a grant cycle and I move to the next thing, but he's done the same kind of thing from multiple directions for decades. It's nobody does that.
Yeah, I'm always impressed when I get to meet somebody that's like a true expert in one area where they just like intensely focus on it. And it's just, to me, it's just fascinating just asking folks like that questions and try to kind of pick their brain on those topics. It's really neat.
So, Fred, as a generalist,
say on this one here, what's interesting here is since most of us we learn by listening. At least the society we're in today, we learn by listening, and by having a book like you can listen to like that and just listen. Your podcast is no different.
Right.
You could send out pieces of paper out to people, but since most people enjoy listening and learning, that's why all the TV shows are so popular. Nature shows, because we can see things in action. That's what to me makes it of interest for me to go find that particular book and for me to listen to it, so I can see what he's seeing, so I can add in to the missing gaps that I have. So that will be a book that I'll have to go and get to be able to listen to as well.
Well, Fred, do you have, I understand being a generalist, but is there a book that you sort of like, or an extension publication that really, you want people to know about, even if it has nothing to do with bees?
We got 150 of them on our website. So you're going to show them about the complex life of the honeybee, and I think that would be one that I would hope that they would enjoy, because that comes from the minds of lots of different people. And it's much the same way Max was saying, experts in their specific areas. So, for me, I still like Rachel Carson's book. I still think that's, I go back to it. It's a very easy read. It helps to set up what it is that I'm trying to do today. We need these particular products to have production to protect our homes against termites, mosquito diseases. So, I liked her approach, and she's really a storyteller herself, though people could argue about specific points. So, you had asked about what could have led me to go to this storytelling. It probably goes back to Rachel Carson, how she took a lot of science and put it together to have her point of view, obviously. But it's storytelling is what I try to accomplish. And that's what I enjoy, listening to people tell stories, not just all of the science. How does that science apply? So that's why I was interested in Max's book that he had on that he could listen to. So.
And that's fantastic. Well, it's a great book.
What's your book? What's your book?
My book?
Yeah.
Oh, geez. Nobody's ever asked me that question.
Well, it's about time somebody did put you on the spot.
I don't know. Gee.
What's your go-to book? Do you have one?
Go-to book. Oh, man. You know what book I really like, maybe along the lines of Max's suggestion? I really like Bern Heinrich's Bumblebee Economics, being put on the spot, because it is one of those, studies, long-term studies of, a kind of a question that leads to another question that leads to another question, as science often is. And I just find, maybe I'm a little nostalgic, but it seemed like it's very hard to do that kind of a research program these days, where you kind of dedicate yourself to a question and you just pursue it with, no expectations, and you're doggedly holding on to it. I don't think that happens that often. And this book is just like that. And it also, reflects what you talked about, Fred. Bird is a remarkable communicator, and he can take the science and sort of write it in a way that any person could follow the story and doesn't have to understand the graphs or. Yeah. Yeah. But I think Rachel Carson's such a great example, a great book, because it is that kind of like taking something complex and kind of, laying it out, but also it's, in many ways, the birthplace of environmental hazards, the regulation of those hazards comes in the wake of that book.
And you and I have jobs because of her concerns. Max has got a job because that required USDA and EPA to create a system to evaluate these products. It wasn't all about, will they control this pest on these crops or protect my health from mosquitoes or my house from termites. And so it's actually allowed us to better quantify what we do, so that people like you and I can always say, read the label, because then we say that's where all the science is at. The science is in the application, put it into use. So, I just thought, and what I try to do then is build consensus. It's not just me saying it, but I bring in a team of people with different viewpoints, attitudes, and can we build consensus and bring it all together where we can all agree on certain parts or certain things that we can make some pretty strong statements.
I have to say that's one of the remarkable parts of this book is, oftentimes, I've written my share of extension publications, kind of go to my inner circle and I come up with something. What's remarkable about this book is you went outward. You sort of like brought in everybody to write this thing. That's remarkable. My next publication is going to be done differently.
Good deal.
Okay. The second question is, do you have a go-to tool for the kind of work that you do? Fred, do you want to lead this one off?
Yeah. So my go-to tool is there is science and there's labels. But the go-to just happened the other day. We've already started our mosquito application. That's what I'm in right now, obviously. And a beekeeper had asked a mosquito person, can you just let me know? Can you notify me? He's not required to do that, but he says, sure. So he calls this person whenever he's going to make an application. Though I read the label, I've looked at it, there's no need to be concerned. But he says, you know what? You took the time to ask me. I'm glad to do it. So for us, we have something that's called Bee Check, where we have our beekeepers put their hives into a database, and then I can actually check that database because beekeepers, as you well know, are pretty secretive. They don't want to make phone calls to me, the applicator, let's say ag, and so that you can, in fact, check it. And what's nice is they update it once a year, and then it will bing me when I have beehives in my area. And so to me, that's a go-to in trying to make sure that I'm a good steward of the product. I'm a good steward of what crops we're trying to protect. And then I'm also a good steward to the beekeepers because I don't want to hurt anybody's bees and beehives because they have a livelihood that they're trying to, it's for many, it's beyond just a hobby. They're selling something or they use it for cooking or their own stuff. So for me, we have something called Bee Check that allows these men and women who are making applications across the industry to check things.
Well, we'll put a link to BeeCheck in the show notes, and we actually have a podcast episode on BeeCheck, so check it out if you're interested, listeners.
So you have it out there?
No, in the state of Oregon, the beekeepers decided, when they were, and the Department of Agriculture looking at it, there's so much mobility of colonies in the state. They really move so often that it seemed like being able to track those locations would be. And so in our situation, we went with meetings between industry and beekeepers, frequent meetings.
So that is a major difference between where I'm at here. We probably have half a dozen men and women who move hives around for pollination, which is much different than Michigan and Florida out there where you're at in Oregon. So ours are more, I guess you call them in-place hives. But there's got to be another system out there, right, that I can know where. There's got to be, at least that helps us to know that something is there. What can I do to call somebody? They can cover their hives or, do certain things, or I know when to spray off the pollinating times, right? Maybe I can spray closer to the evening or whatever. So it's helped us a lot here.
Yeah, that applicator, a beekeeper communication and just, getting in the habit of, and just knowing, aerial applicators coming in and, they're super, when I ever talk to aerial applicators, they're super cautious about bees. But it makes their job a lot easier when they can, they plan their flight plan and they can see where, the bees are before and then they don't have to, turn around because, no applicator wants to do that. Yeah.
If there was one good thing in Max from colony disorder was it raised that level. I've been through this 14 cycles of bee kills ever since I was young in this field. But that's sort of standardized, correct? It made us a lot more aware of the seriousness of lots of factors. And it seemed like now that everybody understands that pollinators are important. That's a major step forward for people to say, okay, this is part of the environment. We got to make sure for many, many reasons. And so your comments there, that, it takes a lot to change people's attitudes and viewpoints as we go forward. But it is part of our psyche now. It's part of what we do. It's what we train on. It's what we apply. And for this man to say, not a problem, I'd be glad to notify you how important that is to that between those two parties. So,
Max, how about you? Do you have a go-to tool?
I think I took the question pretty literally. So mine would be the Hive tool.
I know Hive tool is a very well worn on this show. So but you have to be more specific. Is it J?
I like the ones that have the square ends.
Okay, me too.
The J.
No, you'll pull your frames apart. So you keep bees then?
I used to. I wasn't very good at it, and my ego can't take any more failure. So I stick with gardening. But yeah, I do have an appreciation for what beekeepers go through in terms of keeping hives alive. So I definitely have firsthand knowledge of that.
Yeah, it's always wonderful to watch a commercial beekeeper work a hive. They're the subtle hand movements, the hive tool, it never gets put down. It's always in the palm of their hand. And it's kind of like they butterfly through the frames. It's quite, I guess they've been doing so many of them, but it's always great to see somebody who knows how to move through a colony and how quickly they can move without upsetting the colony.
And it's quickness, but it doesn't look quick. It's just so smooth. Mm-hmm. And yeah, mine's more of a nervous kind of. I look like I'm moving fast, but I'm not getting anywhere quick. So.
Well, our last question is: do you have a pollinator species that you are, when you see it go by, you're like, oh man, I love that little critter.
Go ahead, Max.
Yeah, so I've lived in the Southeast for now most of my life, and I often grow blueberries. And if you think about, here in North America, we have very few actually native fruit species. So like blueberries and pawpaws and cranberries, and there's not a whole lot. And so there's one particular pollinator we have here in the Southeast called the Eastern bumblebee.
No, it's the blueberry bee.
I'm sorry. Yeah, the blueberry bee.
The Hyperpoda.
Yeah, and it's so this genus is not Bombus, it's different. I'm not a taxonomist, but this guy's really cute. So I always enjoy seeing them when they're actually pollinating the blueberries. So I grow rabbit eye. It's one of our native blueberries here in the Southeast, and so it's really interesting to see this specialist bee at work, and definitely appreciate that.
But they look, we have Hyperpoda in Oregon. There's a whole bunch of them. There's one, in fact, that lives in the dunes on the coast. But they look like bumblebees. Like they're a very fast flying, furry critter.
Yeah. It looks just like a little bumblebee.
And the ones in blueberry in the Southeast they're black, right? But they've got a little stripe on them. Yeah.
Yeah, they have some stripes, but they're mainly black. Yeah.
Yeah. Okay. Well, great bee. Thank you so much for that one. Fred, can you top that?
Actually, I've got two, and one of them is I still like the big old bumblebees.
Oh yeah.
Because I have a grandson that's 7.5. Well, you can see them, you can hear them, you can follow them. And it makes it really neat when you're following this thing, how they're trying to cut through petals. There's a lot of biology that's taking place right there that's easily seen and heard. And so it's one of my favorites because of my grandson. We can do things. And then for me, it may be the ones that you're talking about. It's all of the pollinator species that mimic honeybees.
Oh, yeah.
The wasp. So I can go at a set of flowers, and we got a couple acres of plants and stuff, and I can just sit there and watch just at one big bush that attracts them. You can watch all of this multitude of pollinators, and I never appreciated that until I just started sitting still and looking. And so when people talk about pollinators, I appreciate more today because for me, it was more honeybees. I mean, we raise honeybees like we do cattle. But when you're there, there's just this multitude of life, but all of them mimicking these ones that have stingers, which is pretty cool.
It's pretty cool. It's remarkable. It does make me want to change my book suggestion now. There's a book from the early 20th century. No, I'm going to do it anyways.
I only had one.
Do you know Anna Botsford Comstock's Handbook of Nature Study? I love how it goes from rocks to like universe. And it has a great section on bees, but they're just the way you described it with your grandchild being able to, they're these nice little short exercises, but they're not the kind of exercises you might get in entomology that are just they're not specific. She went into great depths to come up with real activities with each of I don't know how she did this, but there's just it's like 1,000 pages long. It's remarkable.
Those I call them the old timey. I think she was from the 40s. I don't know that. I may be off couples.
Yeah.
But a lot of those Comstock books, they were biologists who also enjoyed nature. I am a biologist who does what I do for a specific reason.
Yeah.
I enjoy nature, but I have another job to do.
Yeah, me too.
Right?
Yeah.
Yeah. And so when you read the old Comstock books and all of these old naturalists, you get that flavor of this is how these animals are thinking and living, which makes it much different than today's. We write pretty harsh and straightforward.
Right.
You could almost, through her book, you could almost hear the bees buzzing and the birds singing, right? I mean, it's one of those ways of writing that is just impressive on those old nature. And they were scientists. I mean, her and her husband both were scientists, but these scientists that could write and blend in the sounds, the smells, and all that. And that's what makes those kind of books that you talked about so enjoyable.
Well, I completely agree. It's kind of a lost art, but I do have to say that The Complex Life of Bees is a remarkable book. I really, when I first saw it, I was kind of like, and I kind of thought I was good at doing my job. And then I saw, I was like, man, I gotta up my game here a bit. It's been
I need to hire you as a distributor here to bet on making money off of this. So.
Well, we'll be distributing this in Oregon for sure. I'll be using it for as much as I can. But thank you so much for taking the time to speak with me. Congratulations on the publication, and I look forward to talking to you maybe in the future, Fred, on mosquitoes.
Be glad to. Max, good to see you again.
It's good seeing you, and thanks for the invite. I appreciate it.
Thank you so much for listening. The show is produced by Quinn Sinan Neal, who's a student here at OSU in the New Media Communications program, and the show wouldn't even be possible without the support of the Oregon Legislature, the Foundation for Food and Agricultural Research, and Western SARE. Show notes with links mentioned on each episode are available on the website, which is at pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's several ways to connect with me. The first one is you can visit the website and leave an episode-specific comment. You can suggest a future guest or topic, or ask a question that could be featured in a future episode. But you can do the same things on Twitter, Instagram, or Facebook by visiting the Oregon Bee Project. Thanks so much for listening, and see you next week.